Good day, everyone. Our lesson for today is all about super hexagon and its identities.
This is a hexagon. This hexagon has 6 vertices, which gives us 3 diagonals. So each of the vertices has names. So we give the 6 functions to the 6 vertices. First, let's write here tan. Next, sin, cos, cot, cosec, and sec. Cot is opposite to tan. Cosec is opposite to sin, and sec is opposite to cos. Now, we have one in the middle of the super hexagon. So now that we have learned about the super hexagon, let us now move into the product identities. So in the product identities, if we multiply the function by its opposite vertices, then we will get a 1. For example, sin theta times cosec theta is equals to 1. Cos theta times sec theta is equals to 1. Tan theta times cot theta is equals to 1.
Hello guys! So for today's video, this will serve as the part 2 video on finding the product identities using the super hexagon. So this is just the continuation of Rachel's video. So earlier, she discussed how to get the 3 product identities. And as for me, I'll discuss you the 6 product identities on how to get that. So it's just easy. Just stay tuned.
The first thing we gotta do is to draw the super hexagon and label the 6 trigonometric ratios.
So the first thing we gotta do, guys, is to find the consecutives, the 3 consecutives functions. So we have here tan, sine, and cos. So let's begin with these 3. So to find the multiplier of tan, we need to skip one function. So in this case, this is sin, and the next to sin is cos. So we will have tan theta times cos theta. And then to find the product of these two is equal to, we need to find the function in the middle of them. So what's the function in between tan and cos? It's sin, right? So the sin here will now serve as our product of these two, tan and cos. So is equal to sin theta. Now that the first product identity is already at hand, guys, there's still 5 left that need to be searched. So the same process. So here, the product of tan and cosec would be equal to sec, since it is the function between tan and cosec. So write it down. Tan theta times cosec theta is equal to sec theta. And then the same here. The product of cosec and cos would be equal to cot. Okay, so let's write it down. Cosec theta times cos is equal to cot. Here, guys, notice that tan, cosec, and cos haven't been encircled yet. So we need to encircle them, meaning we need to make them a product Also, that's why we need to find their corresponding multiplier and multiplicand. To do this, guys, we'll still be having the same process. So to make tan as our product, we have to multiply the functions that is beside tan, which is sin and sec. So sin multiplied by sec is equivalent to tan. So here, let's write it down. Sin theta times sec theta is equal to tan theta. Now, to make cosec as our product, we also have to find its multiplier and multiplicand, which is sec and cot. So, sec theta multiplied by cot theta is equal to cosec theta. Now, for the last one, which is cos, we have to multiply sin times cot is equal to cos. So, sin theta times cot theta is equal to cos theta. So, that's it, guys. To do this, guys, we'll still be having the same process. So, to make tan as our product, we have to multiply the functions that is beside tan, which is sin and sec. So, sin multiplied by sec is equivalent to tan. So, here, let's write it down. Sin theta times sec theta is equal to tan theta. Now, to make cosec as our product, we also have to find its multiplier and multiplicand, which is sec and cot. So, sec theta multiplied by cot theta is equal to cosec theta. Now, for the last one, which is cos, we have to multiply sin times cot is equal to cos. So, sin theta times cot theta is equal to cos theta. So, that's it, guys.
Hello everybody, my name is Travis John Mantiam and today I will be showing you how to find quotient identities using a super hexagon. So quotient identities, there are a total of 12 quotient identities, but today I will be showing you how to find 4 of the 12 quotient identities. So let's begin. Here we have our super hexagon and it's labeled with each function at each vertex. So let's start. How do we find a quotient identity? So using the first identity, we actually use the first identity in order to even label our super hexagon. So we usually start labeling our super hexagon with tan is equal to sin over cos, right? And then once we have those three, we can use those three to find the other labels for each vertex. So that's already one of our identities. So how do we find that? So here, if we start with tan. Tan, or the first vertex, is equal to the second vertex divided by the third vertex. So we're just going, we're going clockwise 2 vertices from the beginning, from the one that we start with. So we start with tan, so we go 1, 2, and it's divided by these 2. So tan is equal to sin divided by cos, or sin over cos. And that's how easy it is. We just go clockwise 2 vertices from the beginning vertex. So let's say for the second identity, sin, we go 1, 2. So which one is the 1, 2? The first one is cosine and the second one is cotangent. So now we know that sin is equal to cosine divided or over cotangent. For the third one, it's the same. Cosine is equal to cotangent over cosecant. The fourth one is the same thing. Cotangent is equal to cosecant divided by secant. So what you need to know is you can start from anywhere. So let's say we start from cosecant. We just go clockwise two vertices, and that's our identity. Cosine is equal to cotangent divided by cosecant. And that's how you find 4 of the 12 quotient identities using a superhexagon.
Okay, so hi, I am then Virgil Bailon, and I will be proceeding to 4 more quotient identities. So, as TJ said earlier, the pattern goes like this. First will be equal to second over third. So, if we proceed to the last two quotient identities that are clockwise, we have here cosec. So, cosec theta will be equal to sec theta over tan theta. So that's first is equal to second over third. Now if we proceed to the last one, sec, if we have sec here, sec theta will be equal to tan theta over sin theta. So that's the same pattern. Now what if you have anti-clockwise? Well, it's the same pattern as clockwise but in reverse. So let's go back to the first one. We have tan but in clockwise. Let's try. Tan theta will be equal to sec theta over cosec theta. Now, if you're asking why is it going here when last time it was tan is equal to sin over cos, but that's because it's anti-clockwise, and so we go reverse this time. So same pattern but just reverse. Tan theta is equal to sec theta over cosec theta. And if we proceed to the second one, sin clockwise, so that's sin theta is equal to tan theta over secant theta. So that's it. That's 4 more quotient identities. So yeah.
Hello and greetings to you all. My name is John Cristiano Sumion. Today I'll be teaching about quotient identities. There is a total of 12 of it. But today I'll be teaching about the last 4, which are in the anti-clockwise formulae. The 4 quotient identities that we will be answering is this: quotient, cotangent, cosecant, and secant. But we will be doing it anti-clockwise. So for quotient, it will be quotient equals sin over tan. So sin over tangent. Next is cot. Cot equals quotient over sin or sine. Next is cosecant. Cosecant equals cotangent over cos. So cosecant equals cotangent over cosecant. And lastly, secant. For secant equals cosecant over cot. This is how you answer it.
Other identities that we can find at our superhexagon is the Pythagorean identities, and we'll be talking about that in this part. So, as you can see here, we have our superhexagon, and Going at a clockwise direction in this part, we will be finding 3 Pythagorean identities. We will be focusing here at the 3 triangles, as you can see here that I have shaded, and going at a clockwise direction. For the first one that we can find is this one. As you can see here, we have sin, cos, and 1. Going at a clockwise direction, looking at this arrow, clockwise direction, we can get sin squared plus cos squared is equals to 1. And all of the identity here is squared for our Pythagorean identities. That was one of the identity that we can find. Sin squared theta plus cos squared theta is equals to 1. Next one, in this triangle, tan, 1, and sec. For this one, we can have tan squared theta plus 1 is equal to sec squared theta over here. Next one, in this triangle, as you can see, going at the clockwise direction again, we have 1, cot, and cosec. And that will give us 1 plus cot squared theta is equals to cosec squared theta. And that we can see here. So that was our 3 Pythagorean identities that we can find at our superhexagon going at a clockwise direction.
Now let's tackle the 3 remaining Pythagorean identities in anti-clockwise form. So before I show you the hexagon for the anti-clockwise in Pythagorean identities, here's the difference between anti-clockwise and clockwise. In clockwise, the arrow in the hexagon goes down, while in anti-clockwise, it actually goes up. And another thing is that in clockwise, they use plus sign before the second term, while in anti-clockwise, they use minus before the second term. So, I'm gonna show you the 3 remaining identities. So, here's the hexagon. As you can see, these are the arrows and how you figure out the identities in anti-clockwise form in the Pythagorean identities. So, here are the remaining identities. Let's read them. So, 1 minus cosine squared theta equals sine squared theta. It's this one over here. Next is cosec squared theta minus cotan squared theta equals 1, which is this one right here. Last but not the least is secant squared theta minus 1 equals tangent squared theta, which is this one.
So, at this point, I'm going to explain the 6 co-function identities that can be derived in super hexagon. So here, I have the whiteboard, and this is my illustration of my super hexagon. Then, I'm going to put the trigonometric ratios. So, I'm going to put tan here, sine, cos, cot, and here is the cosec, since all the c's should be in the right side. And the remaining is sec, and we will put it here. So this is tan, sine, cos, cot, cosec, since all the c's should be here in the right side, and the remaining is the sec, and we put it here. So let's talk about complementary angles. So as far as I remember, 2 angles are complementary angles if their sum is 90 degrees. Also in trigonometry has a special relation with complementary angles. So here I am going to explain the one of the co-function identities. So here I have my super hexagon here, and I draw a horizontal arrow which we can derive it into identities. So I'm going to write. So sine theta is equals to cosine 90 degrees minus theta. So this is the first identity that we have. So the horizontal arrow is the sine of an angle is equal to the cosine of the complementary angle. Next, we're gonna move into the next identities. So here, we have the tan and the cot. So I am going to draw a horizontal arrow. Horizontal arrow. Here we have the horizontal arrow now. So I am going to put it on the identity. So tan theta here, tan theta is equal to the cot of 90 degrees minus theta here. So tan theta is equals to cotangent of 90 degrees minus theta. So it means that the horizontal arrow is the tan of the angle is equal to the cotangent of its complementary angle. So we're going to move to the next co-function identities, which is the sec and the cosec. So how we can derive it into co-function identities. So we're going to draw a horizontal arrow again. So here, horizontal arrow. So let's derive this into like this. So it's sec theta is equals to cosec of 90 degrees minus theta. So this is the another co-function identities. So the sec of an angle is equal to the cosec of its complementary angle. Now we have the three co-function identities. So we're going to reverse this one. So the arrow is from here. We're going to reverse the arrow. So it's like this. So we're going to reverse it, diba? So the arrow is from cosec to sec here. So if we're going to put it on a identity, so it's cos theta is equals to sine of 90 degrees minus theta. So this is the reverse version of this one and this one. So here, the next one is the tan and the cot. We're going to reverse it. So from here to here, we're going to reverse it. So we're going to start from the cot to tan. So the result will be cot theta is equals to tan of 90 degrees minus theta. So this is the reverse version of the cot, tan and cot. Next, the last one, the sec and cosec. So the arrow is here to here. We're going to reverse it. So we're going to reverse it from sec to cosec. We're going to reverse it, so it from cosec to sec here. So we're going to derive it from like this. So cosec theta is equals to sec of 90 degrees minus theta here. So we have sine theta is equals to cos of 90 degrees minus theta, so on and so forth. So the horizontal arrow will tell us one function of an angle is equal to another function of its complementary angle. So I conclude that there are 6 co-function identities, and I am going to list down it here. So this is the final 6 co-function identities here. So we have the sine theta is equals to cos of 90 degrees minus theta. Next is the tan theta is equals to cot of 90 degrees minus theta. Next is the sec theta is equals to cosec of 90 degrees minus theta. The reverse version is the cos theta is equals to sin of 90 degrees minus theta. Next is the cot theta is equals to tan of 90 degrees minus theta. The last one is the cosec theta is equals to sec of 90 degrees minus theta. So that's it for the co-function identities. Thank you for listening.
That's all, everyone. Thank you for watching.